Welcome to the bonus project.
where we answer your questions about atmospheric science.
You, Rachel, what is the Hadley cell? Amber's asking.
Yeah, so that's a great question, Amber. So the Hadley cell is one of three main circulation cells on planet Earth. And circulation cells essentially help us transport things like heat and weather and energy across the globe. So the Hadley cell is the first cell that connects the equator to the mid-latitudes.
You have another question. Where does wind come from? Rachel kind of answered it a bit, but I'll get into it a little deeper. It's basically just from temperature pressure gradients. As higher pressure is warm air, lower pressure is cold air, and air flows from low pressure to high pressure. And then that's where our cells form. A question from Brigitte. Ma tante Brigitte, biz.
Woo! Ma tante Brigitte!
Ma tante Brigitte demande, c'est quoi au juste un vortex polaire? Le vortex polaire est à cause le jet stream qui se promène entre la cellule ferrée et la cellule polaire, juste comme il y en a autour du monde. Ça peut changer de place quand la température change en hiver. Quand la température descend en hiver, le jet stream descend parce que ça juste descend avec l'eau chaude.
C'est ça.
Fonction de température. Puis quand le sud vient plus froid, le jet polaire descend au sud et apporte de l'air froid avec lui. C'est juste une poche d'eau froide qui descend.
C'est ça.
On n'aime pas le vortex polaire.
Non, ça devient bien trop froid quand il y a le vortex polaire ici. So now we have a question from Pat, and just to preface this question, Pat lives in Sudbury. Now, Sudbury is known as a place that can have really wild temperature, day-to-day temperature differences. So Pat's asking, why does temperature fluctuate more in the winter than it does during the summer? And the answer to that actually plays off the question that we were just talking about, just has to do with the jet stream. If you're ever confused about an atmospheric science contest, 9 times out of 10, it's just that damn jet stream, I'm telling you. So, like we were talking about, the jet stream really controls a lot of the wind and the temperature in Canada as it divides the warm air to the south, the cold air, coming from the Arctic above us. During the summer, the jet stream is really to the north of most of the habited places in Canada, and especially Sudbury. Sudbury is, pretty far south, which means we won't really have as much day-to-day temperature fluctuation as we would say in the winter. During the winter, that jet stream can actually pull as far south as the northern US states. Sudbury is going to be more north than that, right? Super cold because we're getting that air from the Arctic, and Arctic air is so cold. That's really where you're getting your minus 40 temperatures from. So this really makes the day-by-day temperatures fluctuate a lot because the jet stream can drastically change location in the winter, whereas in the summer it doesn't really move as much.
We have a question from Amber. Why does Halifax get nor'easters? The name northeaster is derived from the direction of the wind. So a northeaster storm will get northeastern wind. Northeaster comes from? It comes from Florida, so everywhere in that track. Sometimes New York, Boston, along the ocean. Definitely Halifax and definitely Newfoundland sometimes. And then it just dies out in the ocean. That's why Halifax gets lots of nor'easter snow, because it's in the way.
That's right, yeah, just in the way there. Alright, so the next two questions really have to do with the sun, so that's why I grouped them together like this. So the first one comes from Chantal, and she asks, why are we seeing more northern lights in our area as of late?
So, noticing that.
Yeah, so northern lights really has to do with something called a solar storm. And essentially what a solar storm is when the sun, gets all excited and releases all this excess radiation. So this radiation really only affects that top layer of the atmosphere. So essentially what's happening there is all that radiation is coming in, it's messing with the air molecules in the thermosphere, and the result of that is the northern lights. So they say that, well, there's more northern lights because there's more solar storms, but explaining why there would be more solar storms would be a whole question by itself, so I'm just going to leave that one up to independent research. We're going to move on to the next question.
Why does the sun set so early in the winter?
So yeah, this has another one to do with the sun, like I said before. And that's really just because the Earth basically has an elliptical orbit around the sun. Actually, during the summer, the Earth is much closer to the sun. So that means as the Earth is rotating, we're getting a lot more coverage from the sun during the day, and that makes our days longer. But in the winter, the Earth is very far from the sun, and that means kind of as the Earth rotates, you're going to get less light hitting the earth as it's spinning, which means our days are shorter. So that's why the sun sets so early in the winter as compared to the summer. So now we have a question from Alexia, and she asks, why does the temperature fluctuate between increasing and decreasing as we move through each layer of the atmosphere? And Derek also asks, can you please explain the thermosphere in layperson's terms? So I've combined these questions into two because they actually do have to do with each other. The atmosphere is composed of 4 layers. The troposphere, that's where we live, the stratosphere, the mesosphere, and the thermosphere. Temperature changes drastically in different parts of the atmosphere. So first of all, the troposphere is where most of the gas in the atmosphere is found. Gases have different absorbing and emitting properties for radiation that explains the different temperatures in each of the layers. Now, like I mentioned before, a lot of the gas in our atmosphere is found in the troposphere and really in just that lowest part of the troposphere. But why is this? Well, that's because in more recent years, due to pollution, we see a lot more greenhouse gases. So those gases are really, really good at absorbing and emitting the radiation that we see from the sun. So since there's more gases lower in the troposphere, evidently as you go up there'll be less gas. It'll be less hot in the troposphere. So that's why as you go up in the troposphere, temperature decreases with height. Now onto the stratosphere. By far the most important gases in our atmosphere is ozone. If we have a lot of ozone really close to the bottom of the stratosphere, which would be the top of the troposphere, then you are going to see temperatures start to increase because ozone is absorbing and releasing a lot of that heat. Temperature will increase with height in the stratosphere. Sort of similar to the troposphere, there's a lot more gas in the bottom of the mesosphere than there is at the top. So as you're going up in the mesosphere, there's less gas and the temperature decreases with height. The thermosphere is very similar to the stratosphere because there's a lot of gas that's sensitive to radiation coming from the sun there. When you're going through the thermosphere, temperature increases with height. It's a big zigzag right through the atmosphere.
We'll put a graph about that right now.
Here comes the graph. Question comes from Jillian, and she's asking, what are clouds? And honestly, that's such a fair question. Let's answer that question now. Clouds are essentially a collection of water droplets in the sky. Since water is really reflective, we can see all of these little tiny droplets grouped together within a cloud. There is a lot of water vapor present in the troposphere due to evaporation off of lakes and oceans. So the water vapor then condenses onto a small particle called an aerosol. Now, aerosols really just help water droplets grow, and aerosols and greenhouse gases essentially mean the same thing. There are a few differences, but for the purposes of this video, aerosols and greenhouse gases are the same thing. These aerosols take that condensation of water and they turn into cloud droplets. So as more water vapor condenses, the cloud droplet grows larger and larger and starts reflecting so much light that we actually, start to see clouds. So this mechanism really provides development of clouds. So next we have another question from Alexia, and she asks, why do tornadoes primarily happen in the States?
So there are 4 things you need for a tornado. It's called mist, moisture, instability, wind shear, and a trigger. A trigger could be a cold front, a sea breeze, or some surface heating, just to get that vertical motion up and running. As we know, the States is a very dry place, and they're not used to getting as much moisture as we do. So when they get moisture, it really triggers a whole bunch of things. So we need instability as well, and instability could mean essentially things like CAPE, which is something we learned in our class. I'll put in a picture. T1P diagram.
Basically showing how temperature changes with height.
Things like CAPE is very important, a high CAPE. Shear, if the shear is not high enough, the rain can fall into updraft and cool, and it just kills off convection. Shear is also a big way that we categorize, if it's a supercell or just a squall line. We have our trigger, without a trigger, all of that won't go into play.
To fully answer the question, tornadoes don't only happen in the States.
Yeah.
It's just that the States really have all of the key factors in mist, so that's moisture, instability, trigger, and shear. But really anywhere with those 4 conditions being met, like Alberta, sometimes Southern Ontario as well, you can really have tornadoes anywhere where those criteria are met.
Yeah.
Okay, our next question comes from Tammy, and she asks, how can we have hail when it's hot? For example, during summer thunderstorms. So basically, if we had a cloud that was almost at the surface, the base is at the surface, and the top is really high up in the troposphere, the bottom could be really hot, but the top could be so cold that it's actually below the freezing point for water, which is 0 degrees Celsius. So yeah, so this is exactly what happens in a thunderstorm. A thunderstorm really can only happen in a cloud that has a lot of what we call vertical extent. So that basically just means it's really, really tall. As it's going up and growing in the cloud, it's really slow as it's going up, and it's growing and it's growing and it's growing. And suddenly it hits the top and it's really cold. The temperature is so cold actually that the water will start to freeze. When the ball of ice gets big enough, it will start to fall back through the cloud. But the thing is, the ice is so big and so heavy now that when it falls back through that warm layer, it doesn't have time to go back to the liquid phase and become a raindrop. And so it can actually get all the way to the surface as a piece of ice. That's why ice has really that kind of like spiky look, is because as it's going down through the cloud, water is actually freezing directly onto it. Liquid water is freezing directly onto it. But yeah, so basically this is how we can have ice on the ground on a really hot summer's day. Now we have a question in French this time from Brigitte. Brigitte demande, pourquoi les flocons ont tous 6 branches et à la fois tout différents? Donc, la formation des flocons de neige est toujours unique à cause de la distribution d'eau dans un nuage. La formation des flocons commence avec un petit noyau de glace dans un nuage. Ce noyau est entouré d'eau qui veut se geler sur la surface de glace. Comme la glace est à forme d'hexagone, donc il y a 6 points là-dessus, l'eau crée des branches gelées aux 6 sommets de l'hexagone. Mais la formation du flocon dépend sur la distribution d'eau dans le nuage, qui n'est pas toujours pareil dans chaque nuage. C'est pourquoi chaque flocon est unique.
Mm-hmm. So I have 2 questions that are pretty much the same. Jillian is asking, how do the holes in the ozone layer affect climate change? And then Amber asked, why is tropospheric ozone bad, but stratospheric ozone good? First, we can go with what is the ozone layer. The ozone layer is basically a layer in the stratosphere that is packed with ozone. And as Rachel mentioned, ozone is a really good absorber of UV rays. So long story short, chemicals that come from aerosols that started being produced, like the cans of aerosols, in the 1900s, 1800s, make its way to Antarctica, and the chlorine aerosols go through a chemical reaction in the cloud and break down O3 molecules, ozone molecules, and this leads to the depleting of the ozone layer in the stratosphere. The hole in the ozone leads to cooling of the polar stratosphere. That's usually being absorbed by UV rays. And just like us, the Earth can get a sunburn, unfortunately.
Yep,
and where the ozone is in Antarctica, the Earth is getting a sunburn from the UV rays, which affects climate change. And the reason why it's different, so stratospheric ozone depleting is bad, but tropospheric ozone depleting is good. We know that the troposphere and the stratosphere don't mix. So all the ozone that's in the stratosphere stays in the stratosphere, and then we have ozone in the troposphere that we classify in the troposphere as a greenhouse gas. So we know greenhouse gases are bad because they warm up the Earth. So the ozone in the troposphere depleting is good for climate change because we know that greenhouse gas bad, so it makes it warmer. But ozone in the stratosphere is good for the planet because it absorbs our UV rays.
Excellent. Jillian has another question. She asks, why do we get things like sun showers and snowstorms with lightning? Emma, you want to take this one?
I can. So let's just first say we can get storms without lightning, but we can't really get lightning without storms, or at least like it's more rare.
It's really rare.
Lightning occurs when you have a negative and positive charges that are being pulled at the top of the cloud, positive charges are being pulled at the top of the cloud, negative charges are being pulled at the bottom of the cloud. And when you see lightning, that's when there is an exchange in these charges between the top of the cloud and the bottom of the cloud, or the cloud and the ground, which that's what we usually see. Sun showers, on the other hand, are from strong mid-latitude winds. So if there's sun coming down this way, no clouds, but there's a big rainy cloud coming this way and you're underneath the sun, mid-latitude winds could be pushing the winds from the rain, and that's what you feel. So you look up and you're like, why is it raining? There's sun, but it's actually just the wind.
We have another question. She asks, why does humidity make hot weather feel worse?
Humidity basically hinders the evaporation of sweat. The way we cool off during a hot day is when our sweat evaporates. If the air is humid, our sweat can evaporate. In some cases, some water from the air can condense onto you, making you even warmer than you usually will be. So that's why if it's a really humid day, you're more susceptible to heat exhaustion or
Sunstroke, yeah.
From Lindsay, why do deserts get cold at night?
So you can essentially think of deserts as giant mirrors for the heat coming from the sun. So different surfaces on Earth will reflect the solar radiation differently, and the ability to do that is something that we call albedo. Albedo tells you how good a surface is at reflecting light that comes down onto it. So if a surface has a higher albedo, then it will reflect light better than a surface that has a lower albedo. And generally, light-colored materials like sand, for example, have a really high albedo, and so they reflect the sun's rays really, really well, whereas a darker substance like water in the ocean, for example, is not really good at reflecting the sun's rays. So essentially, the difference here is that because sand has such a high albedo, it will absorb a lot of the heat coming from the sun and then reflect it back out into space. Yeah, so with that all being said, well, I mean, what happens when we take the sun away? So if the desert's temperature really depends on the sun, like we just talked about, then as soon as we take the sun away, well, it's going to be really cold in the desert. There's really nothing there to heat it up. Okay, now on to our first question from Anne-Sophie. She asks, what is lake effect? Do large rivers like the St. Lawrence also have something akin to a river effect? Well, let's start with the lake effect question. Lake effect is a term used to describe the phenomenon in which areas close to really large open bodies of water get a lot more precipitation than areas that are further inland will say. This happens because as the wind is blowing over the water is evaporated into the sky. Clouds really need water vapor from evaporation and a water source to be able to grow the rain droplets so that, they rain, because, not all clouds rain.
Mm-hmm.
Since we've just gone over a huge body of water like Lake Huron, for example, and we've picked up all this extra moisture. So now there's all this extra water inside the cloud, and it goes directly into feeding the raindrops, into making them bigger and bigger, and also making more raindrops as well as cloud droplets get activated. And activation essentially just means going from a cloud droplet to a rain droplet. And so yeah, there's just this big excess of rain now in this cloud. And essentially, as soon as it moves over land, it's not, getting all this moisture anymore. Well, it's all gonna rain out. So yeah, so that's why areas really close to bodies of water see generally a lot more rainfall and precipitation in general than areas that are more inland, and that's the lake effect. Since you only need a body of water, there's no really specified size. I mean, the bigger your body of water is, the more rain you're going to get. But essentially, yes, you can have a river effect and also ocean effect precipitation. Essentially, all you need is a body of water to get, body of water effect precipitation.
And Sophie, you asked a very similar question. Not similar, but has a similar answer. What is a snow belt? Near the Great Lakes, where you get a lot of snow, because of the lake effect. That's why that area gets a lot of snow. So if you're looking to move, look for where your snow belt
Make
is.
sure you know where your snow belts are. Exactly. You don't want to be shoveling snow for days.
Well, thank you for listening to us, and
Thank you for asking the questions as well. Yeah.
And hearing. If you guys have any more questions, you can talk to us personally.
Yeah, exactly. Send us messages. We're happy to answer any questions that you guys have.
This is the bonus show, or the bonus project, tuning out.